Hey learners, welcome to Mac. So learners, in this video we will see a question which came in Amazon coding problem and this can be solved using carry forward. Okay, so let's start. So given an array, we have to return the length of the smallest subarray which contains both the minimum and maximum of the array. So first of all, what is this subarray? So subarray is any continuous section of an array. Okay. So if for example, if this is an array, so any continuous section can be a subarray. This can be a subarray from here to here. Okay, from here to here, this also can be a subarray. Even a single element, this can be a subarray. This can be a subarray. Okay, this can be a subarray, or from this here to here, this can be a subarray. So what we have to do, we have to just see that a subarray which contains both min and max, and the size of the subarray should be minimum. Okay, so you can see that in this array 1 is the minimum and 150 is the maximum. So this is a subarray from here from 0 to 1 index, and this subarray contains both min and max, and it is the length of this subarray will be what, 2. So how to get the length of the subarray? You can see that we can get the length of the subarray by getting the end index and getting the start index, and we will subtract it from the end index, and at last we will add 1. So this is the formula for getting the length of the subarray. So this length of the subarray is what, 2. 1 minus 0 plus 1 will be 2. So if you can see, this is a subarray which contains both min and max. Okay, and the length of this subarray is also 2, because 5 minus 4 plus 1 will be 2. And if you can see, this is also a subarray which contains both min and max, and the length of this subarray is what, 3. So this is bigger than the previous answer, which is 2. So for this array, the subarray which is the smallest in length and which contains both min and max will be 2. So the answer for this will be what? So answer for this will be 2. Okay, now just see that how to solve it. So before solving it, just see that how many subarrays is there in an array. Okay, so just see over here the number of subarrays which starts with 0th index. So if you see that from 0th index, how many subarrays can be there? So this can be a subarray, this also can be a subarray, this also can be a subarray. Like this till here we can just reach, and till here all the elements can be a subarray with the 0th index in the continuous section. So how many numbers will be there? N will be there, the length of the array. So now what can be then the number of subarrays which starts from 1th index? So it will be n minus 1 only. From here to here, this also till going till here, so this will be n minus 1. So number of subarrays which starts from 2 will be then n minus 2. Like this, the number of subarrays which start from n minus 1 will be 1. So when we add all these numbers, we'll get the result as n into n plus 1 by 2. So what can be the brute force solution for it? The brute force solution can be that if we go for all the subarrays, for this or from here also, like this, if you go for all subarrays, then going for all subarrays in an internal loop will take order of n squared, and there will be one extra order of n for the outer loop. So the total time complexity for this will be what, order of n cube, and this is a very large time complexity, so we have to reduce the time complexity. So just see that here is an example. So just first get the minimum and maximum of this array. So in this array, minimum is 1 and maximum is 6. So just see for the min and max which in the subarray. So this can be a subarray containing both min and max, 6 and 1, and the length of the subarray is what? 4. Okay, you can see that this is also a subarray which contain both min and max, and the length of this is what? 3. So definitely for this the length of 3 is less than 4. So the minimum length of subarray in this array which contains both min and max will be what? 3. So this will be our answer. Okay, so what can be the optimized idea? So we can get the optimized idea by seeing this array, that first we have to get what? The shortest subarray that contain both min and max, and this subarray should contain exactly one occurrence of min and one occurrence of max. Okay, so this is also a subarray which contains exactly one occurrence of min and one occurrence of max. Okay, so now just see that, because you can see this also can be a subarray which contains min and max both, but the max in this subarray will be what? 2 times, but we have to get the shortest subarray with exactly one minimum and one maximum occurrence. Now we have to see that in the shortest subarray that contain min and max, the min and max should be at the edges of the subarray. Means that you can see that in this subarray, these are at the edges. Okay, if you, in this also subarray, this is the shortest subarray and this is at the edges. So we have to get this shortest subarray with containing exactly one min and one max. Okay, and this in this subarray the min and max are at the edges. So when we get all these things, we can just get the solution for the minimum length of the subarray. So like this you can say, if this is a subarray, the min and max should be at the edges. If this is also subarray, the max and min are at the edges. Anything can be first, either max or min, but both of this should be at the edges of the subarray. So you can see just an example over here, which in here 6 is the maximum and 1 is the minimum. So just I have represented the max and min over here. So there are 2 elements, then there is a max element, then there are 3 elements, then there is again a max element, then there are 2 elements, then there is a min element, then after one gap there is again a min element, and with 2 gaps there is again max element. Okay, now just see that when we are getting a max, we should get a min at the edge, and that will make a subarray, and the subarray should be of minimum length. So when we start from here, we see a max over here, then we must search a min for this to make a subarray. Okay, and if we see a min, whenever moving forward, if we see a min, then we will search a max to make a subarray like this, and if we see a max again, then we will search a min to make a subarray. Okay, if we see a max, this is at the last index, we cannot move forward, so we will just leave it. So from here you can see that a max can make a subarray with this, and the length of this subarray is what? 8. A max can also make a subarray with this element, but the length of this element will be greater than this, so we will not consider this subarray. Okay, for now let's consider this subarray, and we will store this in an answer. Okay, now move forward. Again we are getting a max, so we will search a min for it. So for this you can see that there is a min, and when this makes a subarray and both of these are at the edges, the length becomes what, 4. So this is less than this, so we'll consider this subarray. Now we will make the answer as 4. So now we will move forward. When now we see a min, so we will search a max for this. So if we see a max over here, the length of the subarray is greater than this. Okay, so we will not consider this. Then we'll move forward. Then here again we are seeing a min, so we will see search a max for this, and when we will reach here, the length of this subarray will be what, 4. So both of this is having the length of 4, so the minimum subarray length for this array will be what, 4 only, and all, and which also which contains min and max in the subarray. Okay, so now just try to write this down, this approach in the pseudocode. Okay, so I have just written a pseudocode over here. You can just try to understand. Then there is a method which is accepting a array. So n is the length of the subarray, min is the taking the integer max value, max is taking the integer min value, and answer is taking the integer max value. Now first we have to get the minimum and maximum in the array. So here we are doing that, taking the minimum and maximum, making the loop run from I is equals to 0 to I n minus 1, and checking that if ai is greater than max, then we are assigning that ai value to the max, and checking if ai is less than min, then we are assigning the ai value to the min. So with this we can get the min and max. Now we have to move further. So now we are taking the L min index and L max index as -1. L min index will be the most recent min index on the left of I. Okay, and L max index will be the most recent max index on the left of I. Okay, now just see. So again there is a loop over here running from I is equals to 0 to I n minus 1. Now we are checking over here that if ai is equals to min, then we will enter in this block. We will assign I to the L min index. Now we are checking that if L max index is not equals to -1, if it is not equals to -1, then there is a max element to the left of this min index. Okay, then we have to get the answer for this by taking the length and comparing it with the previous answer. So answer equals to math.min of, we are taking the min of the previous answer and the length of the subarray between this max index and the max min index. So how to get the length of the subarray? By getting the end index minus the start index plus 1. So I is the end index, L max index is the start index plus 1. Okay, now with this we can get the answer. So now move further. So else if we are here, we are checking that if ai is equals to max, then what we will do, we will assign this ith index to the L max index. Now what we are checking that if L min index is not equals to -1, if it is not equals to -1, then there is a min index to the left of this max index. Then again we have to evaluate the length of the subarray with the previous answer. So the answer becomes what, math.min. We are taking the min of the previous answer and the length of the subarray. So how to get that? I minus L min index plus 1. So with this we can get the answer of there is a max and min index. Okay, so now when on the loop ends, the answer variable will contain the length of the subarray with minimum length and containing both min and max. So and at last we will return the answer. So now what is the time complexity for this solution? So you can see that in the solution from here to here we will move for this loop. It is running for n times, so the time complexity for this will be order of n. Okay, now for this loop, so for this loop from here it is going till here. Okay, so this loop is also running for n times only, so this will be of what also, order of n time complexity. Okay, so whatever the final time complexity, it will be order of n plus order of n. So the final time complexity will be order of n plus n will be order of 2n, and we remove the constant from the time complexity, so final will be order of n. So you can see that previously with the brute force solution it was taking order of n cube, and with the optimized solution it can be solved in order of n time complexity. So this is the optimized approach for this problem. So, and you can get the solution with this. So learners, this is it for this video. If you like this video, just click the like button. Do comment out in the comment box whatever you liked in this video. If you need to improve anything, just do give a feedback. This will help us in improving our teaching lecture. And do subscribe to our channel. We will be coming with more data structure videos, and hit the bell icon for the latest update. Thank you.